Welcome everyone, and thank you for joining today's webinar on electric vehicle safety. My name is Stephen Downer and I am an automotive service technician apprenticeship instructor at the College of the North Atlantic in Gander, Newfoundland and Labrador. In our program, we introduce hybrid and electric vehicle technology and focus on safety in our Level 1 program, and we cover more complex systems as well as maintenance and service in our Level 4. Today we're going to talk about electric vehicle safety from 3 different perspectives. First, we'll discuss safety responsibilities for hybrid and electric vehicle owners. Next, we'll review critical safety considerations for first responders working around hybrid and electric vehicles. And finally, we'll focus on automotive service technicians and look at some of the best practices around hybrid and electric vehicle maintenance and service. For the purposes of this presentation, from now on, I'll refer to these types of vehicles as EVs. Why does this safety awareness matter? EV adoption is growing rapidly here. Although Newfoundland and Labrador is a little behind than the rest of Canada, we are starting to see more EVs on the road, and people are considering a hybrid or full EV to replace their gas or diesel powered vehicles. EVs are designed to be very safe, but they use high voltage systems that many owners may not be familiar with. It's important that owners, first responders, and service professionals understand how these vehicles differ from traditional gas-powered cars. Understanding basic safety principles helps prevent injury, service-related accidents, reduce fire risks, and ensures that EV owners know how to respond in an emergency. Many safety features are the same as traditional vehicles in EVs, such as airbags and crash protection to protect you in a collision. The key difference is that an EV uses a large battery system instead of fuel tanks. This changes how the energy is stored, how fires can behave, and how the vehicle should be handled after a crash. You may also notice that hybrids and EVs have a noise that's played through the exterior speaker to warn pedestrians of the vehicle while moving slowly, such as parking. EV batteries operate at very high voltages. It's common to see 400 volt batteries, and some vehicle manufacturers are using 800 volt architecture with research and development heading over 1000 volts. While they are well protected, owners should never attempt to inspect, repair, or modify battery components. This work should be left to trained professionals. All high voltage circuits in an EV are identified by orange casing over the wiring harness. Never attempt to unplug or remove a component connected by an orange colored wire. A little later in the service and maintenance section, we will talk a little more about specific safety features of high voltage vehicle components. If a vehicle owner notices a dashboard warning related to the battery or high voltage electrical system, stop driving when it's safe to do so and seek professional service. Here's a close-up view of our Chevy Bolt EV in our shop. Notice the orange colored wiring connecting all of the high voltage components. EVs also have a low voltage system, most commonly 12 volts, that is primarily responsible for operating most of the common accessories and systems found in all vehicles, such as the radio, power locks, lights, and so on. This low voltage system also operates the high voltage circuits. There will be times that an EV won't start or ready up due to a dead low voltage battery. Most all manufacturers of EVs have provisions to boost or jumpstart the vehicles. This is done quite safely with a traditional booster pack or even jumper cables from another vehicle. However, it's important to only use the manufacturer's designated jumping points and to keep the donor vehicle off during the jump start process if you're using jumper cables and another vehicle. Vehicle charging is one of the most common interactions that an owner will have with an EV electrical system. My colleague Dennis will go into more detail on vehicle charging in another webinar, but it is important for owners to use professionally installed and approved electrical supply equipment. Before plugging in, always inspect the cable and plug. avoid using damaged or wet equipment, and never force a connection to your vehicle. After charging, properly store your cable to avoid damage. From both an owner's safety and first responder safety perspective, incidents involving EVs require a little bit of awareness. Despite all the attention they get, according to Stats Canada numbers, EV fires are relatively uncommon, but they can behave differently than gasoline or even diesel vehicle fires. With respect to damage to the high voltage battery, the fire ignition can be delayed depending on how much damage is internally to the battery pack. If you notice smoke, unusual smells, or do any damage to the battery area, move away from the vehicle and call emergency services. Always inform any first responders that the vehicle is electric so that they can follow proper, appropriate protocols. Electric vehicles present new challenges at emergency scenes. High voltage systems may remain energized after a crash, creating an electrocution risk. Also, if the high voltage battery is the source of the fire, it can require different suppression strategies. Most EVs do not make any noise when they're in ready mode, so you can't hear them running. First responders should have specialized training to help them deal with an electric vehicle incident. Recognizing these risks early helps protect responders and bystanders. The first step in a safe response is to identify the vehicle. Look for unique badging with the letters EV. Also look for charge ports or a lack of exhaust system. Emergency response guides, or ERGs, are a great resource to show where the high voltage circuits are and how to respond to these vehicles. Here's an example of an emergency response guide for a 2017 to 2021 Chevrolet Bolt EV. These guides are available online on the National Fire Protection Association and National Highway Traffic Safety Administration websites. On the left page, we see that the guide includes information on the location of the high voltage battery and cables, which are orange in color. On the right page, it explains how to disable all of the high voltage vehicle systems to keep anyone working in the area safe. When in doubt, responders should assume that the vehicle is electric and proceed using electric vehicle safety protocols. Here's a generic quick response guide for electric and hybrid vehicles, also available on the National Fire Protection Association website. Having a high voltage source at an accident scene increases the risk of electric shock and also thermal runaway. Thermal runaway is a fancy way of saying that the battery may be heating up uncontrollably and may catch fire or explode. High voltage cables are typically marked in orange, as we said before. These components can pose serious shock risks if damaged. Responders should avoid cutting or handling these cables and always treat the vehicle as if it were energized. Battery fires can burn hotter and may even reignite after appearing extinguished. Large amounts of water are often needed for cooling, and extended monitoring of the vehicle is recommended. Scene safety and monitoring may go beyond the initial fire suppression, often extending to the towing and storage of the vehicle in a lot or salvage yard. The location of the fire inside the high voltage battery can make it difficult to apply water for cooling, and the battery can reignite if the cell structure is compromised. We will now turn to technician safety during electric vehicle service and maintenance. EVs have fewer mechanical parts than internal combustion vehicles that burn gasoline or diesel fuel. They rely heavily on electrical systems and software. Servicing these vehicles requires specialized knowledge and tools. Services like high voltage battery replacement, high voltage module replacement, cooling system servicing, and even air conditioning servicing can require disabling the high voltage system. So what do I look for? Well, most components on these vehicles, like the tires, brakes, fluid changes, interior electronics, lighting systems, and entertainment systems, are pretty much the same as any other vehicle. The general rule is that if you want to replace anything connected with an orange colored cable, it requires special tools, equipment, and training to do the job safely. The picture on the left is an air conditioning compressor. Notice it's connected with an orange wire harness. This compressor operates on high voltage, and special procedures are necessary to disable the high voltage system before it is safe to work on. The component on the right is a coolant circulating pump. Even though this pump is responsible for circulating coolant through the high voltage controllers, it is not connected by an orange wire, which means it operates on low voltage. This can safely be serviced without disabling the high voltage system. That being said, always consult the manufacturer's service information before servicing. Servicing EVs involves potential exposure to lethal voltages. Only trained and certified technicians should work on high voltage systems. Improper handling can result in severe injury, fire, or damage to the vehicle. Before any high voltage work, the vehicle must be properly powered down and locked out. Personal protective equipment such as insulated gloves and face protection is essential. Always follow manufacturer-specific service procedures, as procedures can vary from one manufacturer to another. Many EV batteries can be removed and opened up to replace individual cells. The batteries themselves weigh hundreds of kilograms, so proper lifting tables are required to safely handle the weight. Although these cells can be replaced, they should never be opened, dropped, or punctured. Damaged batteries and cells require special storage and monitoring due to the risk of thermal runaway. Signs like smoke, heat, swelling, or unusual odors should be treated as serious warnings. After servicing, technicians should confirm that all systems are functioning correctly, that no warning lights remain, so that the vehicle is safe to return to the customer. As I said before, anyone working around or on these vehicles should be properly trained. Newfoundland and Labrador Association of Fire Services offers an electric and hybrid vehicle safety course that's tailored to firefighters and first responders. Automotive dealerships require that their technicians be trained and certified by the manufacturers before authorizing any warranty repairs. Independent shops are finding it difficult to find training. However, training institutions in many provinces have electric vehicle specific training programs. For example, St. Clair College in Ontario offers a diploma program called Electric Drive Vehicle Technician. Nova Scotia Community College, College Boreal in Ontario, RRC Polytech in Manitoba, Holland College in PEI, and various online platforms offer micro-credentials on the introduction to electric vehicle technology. The competency of these courses are at different levels depending on where you go. The College of the North Atlantic here in Newfoundland and Labrador is developing a first responders safety program as well as an electric vehicle maintenance and service program. If you want more information about these courses, please contact your nearest College of the North Atlantic campus. Certifications for dealer technicians will come from the manufacturer, and training institutions will give a certificate when a program is completed. Technicians that meet the criteria and feel that they're ready can go to the Canadian Standards Association, or CSA's website, and register to write their Automotive Electric Vehicle Technician Safety Certification exam. Holding a certificate from CSA will indicate that the person possesses the knowledge, skills, and decision-making abilities necessary to safely diagnose, inspect, maintain, and repair high-voltage systems. Key takeaways. Owners must follow charging and usage guidelines outlined by the respective manufacturers. Emergency responders and technicians must get appropriate training and follow protocols specific to EVs. Everyone plays a role in reducing risk, and as EV technology evolves, ongoing education remains essential. EV safety is a shared responsibility. Thank you for your time and attention during this webinar. I hope it helped you gain a little knowledge about electric vehicle safety. Take care.